Hi everyone! In this video I'm going to show you an analytic method of finding the solutions to systems of equations. First of all, we're going to do a quick review of Math 10C, which is setting up systems of linear equations, and then we're going to do a quadratic linear system as our second example, which is the new thing for grade 11. So just a quick reminder of a Math 10C problem. If we have minus 4x plus 7y equals negative 41, and we have our second equation is x equals y plus 5, then neither of these is really set up for really nice graphing. And in particular, like with this 7 here and this 4 here, like it's going to be an ugly fractional slope no matter what I do. And 41 is like a really big number. Like I don't want to make a graph that goes all the way down to a y-intercept of negative 41. That's just, no, actually, well, not that it would be, because we'd be dividing by 7, so it'd be like 41 sevenths. I don't want to graph that. I hope you don't either. So let's just forget about graphing. Let's just solve this analytically. So what this second equation says is that x is y plus 5. And so that means that this x here is y plus 5 at the point where these two lines are equal. And the point where the two lines are equal is, by definition, the solution. So what we're going to do is we're going to replace that x with our y plus 5 from the second equation. And then everything else we're going to keep the same. Hopefully you remember this from last year. This is solving by substitution, because what we've done is we've substituted a value of x from one spot into the value of x in another spot. And now you just need to do your regular algebra steps, expand and simplify. So negative 4y and negative 20 when you distribute that correctly, plus 7y equals negative 41. Now we're going to collect our like terms. So we have 3y in total, right? Because we have negative 4 of them plus 7. And this minus 20 I want to get to the other side. So I'm going to plus 20. So this is negative 21. And we divide by 3, so we get y equals negative 7. Now, we've solved for our y value, but we have not yet solved for our x value. So what we're going to do is we're going to take this negative 7 we just found for y, and we're going to substitute it back into the other equation. And so this means that we are going to get x equals y we know is negative 7 at the point where these two lines are equal, right? The point where these two lines are equal is where we're allowed to make this substitution. And then we just simplify. X is negative 2. So the solution is negative 2, negative 7. And we could check this by plugging negative 2, negative 7 into our other equation, right? This equation here that we didn't use for our last substitution step. So let's just do that quick mentally. So if we put negative 2 in for x, negative 4 times negative 2 is negative times negative is positive 8. Positive 8, and then 7 times 7 is 49. So positive 8 and negative 7 makes it negative 49. Positive 8, negative 49 makes it negative 41. So yes, that works, right? So what I just did mentally, you should probably be able to do this mentally if you're in Math 20-1. That's what I just did mentally, which you should be able to do if you're in Math 20-1. Okay, let's try another one. Let's do a linear quadratic instead. So let's do y equals negative 2x squared plus 26x minus 70. And let's make our linear equation 16 equals 2x minus y. Now, our first equation is solved for y, so we could do the substitution of this big ugly y all the way over here. I'd rather do it the other way around though, because I can just, sort of flip-flop these to make it y equals 2x minus 16. And then I can set y equal to y. And having y equal to y is really nice because then we can just set our left-hand side is the thing we just found, 2x minus 16. And then the right-hand side is the thing we had before, minus 2x squared plus 26x minus 70. So when we're solving, you want to set it equal to 0 on one of your sides. In this case, the left-hand side is easier. So let's take away 2x. Let's add 16. And so this is negative 2x squared plus 24x. So we take that away, that's going to be 60. 60 minus 6 is 54. So negative 54. Now, we need to solve this for x. I suppose we could quadratic formula. That will always work. But these numbers look not too scary. I think that I can actually simplify this a little bit and turn this into something that's nice to factor. And the first thing I'm going to do is I'm going to get rid of this negative 2 in front. I don't need it. Let's turn this into an a equals 1 trinomial. And we're allowed to do this because you've got an equation here. So 0 divided by negative 2, guess what? 0 divided by anything is just 0. And so now we just need to reduce all three of these things by negative 2, carefully, one at a time. Make sure you don't miss any of them. So negative 2 reduced by negative 2 gives us x squared, which is why we did it. Positive reduced by negative is negative. 24 reduced by 2 is 12. And negative reduced by negative is positive. And 54 reduced by 2 is 27. So now I need to one-step factor this. 0 equals, well, this is going to be x and x, because that's the only way you can get x squared. And 27 is 27 times 1, which would be 28 as a sum, so that's useless, or 9 times 3. And 9 plus 3 is 12. Perfect. And they're both going to be negative. So this gives us two different x values. This gives us x equals 9 or x equals 3. Now remember in our last example, once you found one of your values, you then needed to substitute it into your other equation to get your x value. Well, in this case, we chose to solve for x's first. So now we are going to need to take these x values and substitute each of them in one at a time to find our respective y values. So if x equals 3, then we have y equals 2 times 3 minus 16. So y is 2 times 3 is 6. 6 minus 16 is negative 10. So there is one of your points, 3, negative 10. And your other point is if x is 9, then you're going to have y equals 2 times 9 minus 16. The yellow step maybe you can do in your head, because you're going to get y equals 18 minus 16 is 2. And so those two values give you your other point, 9, 2. So the solutions are 3, negative 10, and 9, 2. So these are your solutions. And as usual, right, if you've got a perfect square, right, quadratics, I'm not going to go through all the examples of quadratics of one example or one solution, two solutions, 0 solutions. Just the same way you'd solve single quadratic expressions for your zeros, you can get 1, 2, or 0 solutions to these as well. And that is linear quadratic systems in a couple examples.